Hello all, and thank you for listening to another video of Mr. Laxton talking through these Algebra 2 notes. So again, here we're looking at section 8.2, which is exponential decay. We've talked a lot about exponential growth in the last couple days, and now we're moving into exponential decay, which is really a lot similar to how we actually do the exponential growth problems, but they do look a lot different. So there's a lot of things in life that decay exponentially. A great example of things that decay exponentially are cars here as we live in Wisconsin. As we live in Wisconsin, we get a lot of salt in the roads, a lot of harsh winters. Your car decays exponentially, and a lot of people say like, hey, when you drive your car off the parking lot, if you buy it brand new, you lose $5,000 by just driving it off the parking lot, which is true. All right, and then it decays exponentially from there. Gets worse and worse and worse. All right, so I do not want to know how much my truck is worth because it's hardly anything at this point. But anyways, exponential decay functions are really, as we look here, is this it's the same equation. It's this f of x equals ab to the x. All right, but notice that this number, this b, the way it's different, this base is in between 0 and 1. So it might be a fraction. It might be like 1/2 or 3/4 or something like that. But it's no bigger than 1, and it's no less than 0. All right, awesome. So really everything else there is kind of the same, but notice here in exponential growth, if we had a graph of exponential growth, it got really, really close over here and then shot up like that. Notice in exponential decay over here, it starts up really high and gets really, really close to 0 on that right side. So that's why as f of x goes to positive infinity, it gets close to 0. Okay. A couple things here. Exponential growth, the b value is greater than 1. And for exponential decay, the b value is between 0 and 1. All right, so that's going to help us here for these first three quick problems here. Do these graphs represent exponential growth or decay? So now to determine if the exponential growth or decay, all we have to look at is this number that's being raised to that x power. Okay, so now we have to say, hey, is 5/8, is that number greater than 1 or is that number less than 1? And we know that, hey, 5/8 is less than 1, so this guy is decay. All right. Awesome. So now we look at this guy, 6/5. Is 6/5 bigger than 1 or is it less than 1? 6/5 is greater than 1, so that is growth. And we look at number 3, 2/3. That 2/3 is obviously less than 1, so that is decay. All right. So that's a good way to tell, hey, is this exponential growth or decay? All right, perfect. So now here it says, for example, number 4, graph f of x equals 4 times 1/2 to the x. So again, this is just my parent function. I always kind of like to just square in that parent function so it has no movements. No moves. All right, no h and k. H equals 0, k equals 0. All right, so it's got no moves, but it can have an h and a k. That's okay. So now let's just go through and plug those numbers in. I got -2, -1, 0, 1, and 2. I kind of gave an extra box there. You can plug in 3 if you wanted, but I'm just going to cross it off. All right, but as we look in through here, as we plug these guys in, I kind of like to just start with 0, like I said. So f of 0 is going to be 4 times 1/2 to the 0 power. Anything to the 0 power is 1, so this is going to be 4 times 1, which is 4. All right, f of 1 is going to be 4 times 1/2 to the first power. And 1/2 to the first power is 1/2, so 4 times a half is 2. And the last positive one, f of 2 equals 4 times 1/2 squared. Again, if you don't know these guys, I'm okay with you just plugging in your calculator, but 1/2 to the second power is going to be 1/4. So 4 times 1/4 is going to be 1. All right, and these guys over here, those negative ones, you can plug them into your calculator or you can just kind of leave them here and that's okay. So I have 0, 4. So these points will give me kind of a good enough gist here. 1, 2, and then 2, 1. So this graph comes in through way up here, as you guys can see. It gets really, really close to 0 over here, but does not go past. Okay, so make sure you're really precise there. You can't go past 0. It gets really, really close to 0. Doesn't go past. All right. Awesome. Domain and range. My domain for exponential growth and decay are both at x equals all real numbers. There's no x value that it gets really, really close to. But my range right here, it gets really, really close to this 0. All right, so that is why my y has to be greater than 0. Okay, so again, that remember there on the bottom, decay models can also have an h and a k to move up, down, left, and right. We're not going to do an example like that, but you guys can. Okay, so decay gets a little bit tougher to graph because you have that fraction. All right, so you have this fraction of that 1/2. It's a little bit tougher, but again, just plug it in your calculator, 1/2 to the -2 power, or whatever it might be, to go through and graph that guy. All right, awesome. So here we go. As we move on, now we have to evaluate. All right, so now we have this exponential decay model, which is y equals a 1 minus r to the t. All right, and as you guys notice here, hey, this equation should look really familiar to exponential growth, but what's the only difference? Is that it's got a minus instead of a plus. Okay, so now we have this. We have y equals a 1 plus or minus r to the t. You have to do some determining for yourself. Am I going to use the plus or am I going to use the minus? So is this specific problem that they're asking me, is it growing exponentially or is it decaying? And that's going to be a huge deal. So as I look at this first one, we got to look at some key words such as E appreciates, depreciates, grows, decays. Obviously, those are all words that help us saying, hey, is this going to grow in value or is this going to decay in value? All right, so example number 6, it says a new car costs 24 grand, but it depreciates at a rate of 18% per year. What is your car worth after 3 years? Okay, so that 24 grand, that is my initial amount. That's how much it costs initially. All right, it depreciates, so that tells me this is going to be decay at a rate of 18%. So I got to move that guy 2 times, so it's 0.18 per year. So that's my R, and then my T is 3. So now I have y equals a 1 minus r to the t, because this is decay. All right, now let's just go through and plug them in. So my initial amount, my 24 grand. Then I have 1 minus my r, which is 0.18, to the t power, which is 3. Okay, so notice here that when you plug this in, when you have this minus 24 grand, and then 1 minus 0.18, that's going to be what? 0.82 to the 3 power. So notice how 0.82, whoa, 0.82 is less than 1, but it's also greater than 0, so that's why this is decay. All right, that should start making some sense. And now you plug this guy in your calculator, 0.82 to the 3rd power. Make sure you do exponents first. Then you multiply it by that 24 grand in your calculator, and you should get a grand total value of your car being $13,232.83. Okay, so that's just after 3 years. All right, so just after 3 years, your car's being down to worth only 13 grand. All right, that's just over half of what you paid for it. All right, that's what it's worth. All right, so that's kind of crazy, but it's, I would say 18% is probably pretty true for around here in Wisconsin. Those cars don't really hold their value. All right, because they get beat up with some ice or the salt and all that kind of stuff in the winter. All right, awesome. So again, thanks for listening to this video. I hope that this helped make some more sense of this exponential decay, and I hope you have a good rest of your morning, evening, or night.